All right, let's take a look at number 2. Hot air balloon rising straight up from a field, level field, is tracked by a rangefinder 500 feet from the point of liftoff. So let's start our picture. So here, I don't know what a rangefinder looks like. I'm just going to draw a box. Here's our rangefinder. Over here, the hot air balloon raises up above the ground. Not the best hot air balloon, but I can live with it. So this is going straight up in the air. It says that the rangefinder is 500 feet from the point of liftoff. So this is 500 feet. At the moment, the rangefinder's angle of elevation is pi over 4. So as it looks up to that balloon, the angle here, we'll call it theta, is pi over 4. And it tells us the angle is increasing at a rate of 0.14 radians per minute. So d theta dt equals 0.14 radians per minute. It's asking us how fast is the balloon rising at this moment. So this change, this vertical change, we'll go ahead and label that y, right? Horizontal is x. So it's asking, what is dy dt at this time? So this is a little bit different. A lot of the right triangle ones that we've done so far have dealt with Pythagorean's theorem, because we're talking about the 3 sides of the triangle. In this one, we're talking about 2 sides and an angle. So Pythagorean's theorem is not going to be helpful for this, because we're dealing with d theta dt. We need to set up an equation that uses theta, x, and y. So we need an equation that relates all 3 of these variables. It's not going to be on that sheet I gave you. This is something different. So we have to look and kind of figure out, what do we have here? We have an angle. We have the opposite side of that angle. We have the adjacent side of that angle. So what relates those 3 things together? An angle, opposite side, and the adjacent side. Hopefully somebody or a few people shouted out tangent. Right? Tangent is equal to the opposite side over the adjacent side. So tangent of theta equals y over x. So here's our equation that we're going to deal with. We've got the d theta dt, we've got theta, we've got x. We want to find out what dy dt is. We want to figure out what y is. So x is 500. Y we don't know, but we can use this equation just like we used Pythagorean's theorem to find the missing parts. We could use this equation to find our y value. So tangent of pi over 4 is equal to y, which we don't know, over x, which is 500. So all we have to do is multiply both sides by 500 to find out what y is. So 500 times tangent of pi over 4, hopefully you know tangent of pi over 4 is just 1. So y equals 500 also. One other thing that we're not seeing here is, what's dx dt? Right? Is that changing at all? Is that horizontal distance changing as that balloon moves up? Right, we're just assuming this balloon is going straight up. So dx dt is 0. Remember in the problems that we talked about before, if the rate of change is 0, if this is constant, right, this is constant because the rate of change is 0. Technically, what we can do here, we don't have to deal with quotient rule. We could, but we're going to make this a lot easier on ourselves. We can put this in here. When we have a constant term, something that's not changing, we can substitute it in. So really, the equation we're dealing with that relates all of these is tangent of theta equals y over 500. Right? We can plug that in because it's constant. So this is our equation. We want to find dy dt. So we have to take the derivative of both sides. You may want to think of this a little differently. Instead of y over 500, think of it as 1 over 500 times y. A lot of you may have the tendency to say, oh, I've got to use quotient rule if it's written like this. Well, 500 is just a constant. Think of it like this, 1 over 500 times y. Makes things a little bit easier. So our derivative, if we take the derivative of tangent of theta, that's secant squared of theta, but we have to multiply by the derivative of theta, which is d theta dt, equals derivative over here, the constant stays out in front, times the derivative of y, so dy dt. So we have to figure this out. We have to take secant squared of pi over 4, because that's what our theta is, times d theta dt, which is 0.14, equals 1 over 500 times dy dt. Secant squared of pi over 4, well, secant is reciprocal of cosine. Cosine of pi over 4 is root 2 over 2. So secant, remember, would then be 2 over root 2. So we're taking that whole thing and squaring it times 0.14. So we've done this before, some problems a while back. Square this, we're going to get 4 over 2. So really this is just 2 times 0.14. Well, that's going to be 0.28. And we have to multiply that by 500. So 500 times 0.28, we get 140 feet per minute for dy dt. Right, 140 feet per minute.